Who's used Git before? Just about everybody, cool. Who's used Git to actually develop software into a repository as opposed to just cloning something else down that somebody else has built? A few less hands, but still a decent amount. What did you all use for it? Is this because you've done it as a hobby project or because you've done it as a requirement at uni? What have you used? GitHub, GitLab, Google? Get some nods? Okay. We're going to largely stick to GitHub, but everything today is broadly applicable to that sort of space. So that's what we'll be looking at. Has anybody used a runner before, or a workflow, or a pipeline? They all mean the same thing. We've got one hand, two hand, a tentative hand. Okay, there's something here for everyone then, pretty much. That's good. So quick little bit about me. My name's Alex. I'm from Skylight Cyber. These days I work in the red team there, so very offensive side of cybersecurity. I come from a very penetration testing, security testing background with a little bit of architecture thrown in there for a couple of years. These days, what prompted this talk is we see a lot more stuff in the CI/CD pipeline, DevOps, GitHub, that sort of world. We'll go through some of what those acronyms mean shortly. But we're seeing more and more companies pivot to these sort of technologies, and they keep doing it wrong. Basically, everywhere we go, somebody screws this up somewhere, and it's probably something people are sleeping on a little bit, and not a lot of people are looking at and hardening. And I wanted to go into sort of some of the common attacks that you can do for that, and what it might look like when you get into the industry, because you are almost certainly going to touch these systems in one capacity or another, either as a developer, as a cloud engineer, as a cybersecurity specialist. You're going to see these things, and a lot of people look at them with a blank stare and go, we have no idea, because they're very non-traditional systems. So we're going to look at that. We're going to look at what runners are, and a lot of this is focused on a runner. I'm going to keep calling it that, but there are other names for it. We're going to look at some practical examples that I've documented and simplified from what we see from real customers in the wild that have massively undone these companies. And at the very end, there is a cheat sheet on a single page if you want to take it away and run through it and look into it some more, or if you are interested in building a CTF challenge based on it, because people should. So as a quick primer, you'll hear DevOps, CI/CD, they're all kind of in the same space. Basically, what used to happen back in the day, if we think about waterfall methodology programming, it was very slow and it was very traditional. If you needed a piece of infrastructure or IT to run a web server, a database, or whatever, you'd have to go to IT, they would provision something, it might be a physical server in a rack. These days, that is not really the case in more and more organizations. More often than not, it's some cloud compute somewhere. Nobody really cares where it is. It's very temporary. We can always create more. And the idea of DevOps is merging that developer aspect with the operational aspect of IT. And this is where some of these problems come from. You're merging a developer or an operational role with something that really needs to be secured properly, and cybersecurity needs to be a factor in that. So you often see DevSecOps merged in there, but often the sec is left out. But these people, it's not their mandate to do this sort of stuff. If you're a developer, your mandate is to make the code work and make the product release on time, basically, and security always comes second. And this is where a lot of these problems tend to come from. A CI/CD pipeline, tool, platform, whatever you want to call it. Things like GitHub, GitLab, Google has their own code repository system. It's the combination of where does your code go, how does it get built, pushed potentially to temporary storage, and then deployed into one or more environments. Often these things go testing, staging, there might be a UAT, might be pre-prod, there might be multiple production environments, and they all have different requirements. Humans don't want to do this anymore. It's a waste of everybody's time for humans to be doing this, especially if you want to be able to do it continuously. So very frequent deployments, potentially every day, every hour, every minute, however fast you need it. You need computers to do that for you. We want to be lazier and lazier, so that's what this is all for. And a runner, or I might call it a builder, is basically just a fancy VM, a virtual machine, a piece of compute. Most of them these days are some sort of cloud-based VM, but not exclusively. And we'll see an example of that. That are spun up potentially for a day, a week, however long we need it. It might be on an as-needs basis. That gets fed some code, maybe some files, and it picks it up and gets some instructions to automatically create potentially entire product environments. These things can be quite powerful because they're creating things that face the internet, that handle customer data, that handle production data. The aim is to take that away from the developer and the operational person, so no human ever needs to touch it. If you want to update production, it needs to go through the code pipeline. You need to deploy the code using Git, and then somebody will approve it. It will go through an approval and review process, and then it gets automatically pushed out in a consistent, testable way. So there's 3 key things that we're going to look out for in some of the examples today. How these CI/CD pipelines can be affected by a rogue developer is kind of the angle that we're looking at it from a red team, from an attacker standpoint, if you compromise a developer's account, or if you're just somebody who's gone rogue for whatever reason. How you could affect the segregation between test and production. This is where it often falls apart. Looking at you, Optus, right now. These things often punch holes in networks that are otherwise, again, humans shouldn't be touching them, and we think that they're isolated away, but these things are often bridging that gap, and that they're not handling secrets, passwords, keys, API keys, things like that, in a secure way, or in a way that's necessarily what a developer might expect versus a security analyst might expect. They could be handled very, very differently. So there's 2 examples. The first one is with developer Dave, and I'm going to focus on this one. There's a little bit of a demo to go with it. But this is based on, for the sake of the innocent, David is not his real name, and we will not name names. But this is based on a real organization. If you've had a vaccine in the last couple of years, this company probably has a medical record with some of your data in it. So you've never heard of them before. You would have no idea that this company exists or that this data exists. But very large Australian I guess, data source for records that is based here that we'll call him David was working for. And because of the pandemic, Dave works from home. He's a developer. He writes code for a COTS product. It's one of their older legacy products. That's all he does. He doesn't touch any cloud stuff. He doesn't develop on their SaaS product. They also have that. That's a different team. He works from home pretty much exclusively. So on a day-to-day basis, he should be accessing company emails and documents. He can change test code. He's not a lead developer. He's not allowed to push changes to the website or push changes to production products. That needs to go through his bosses and through an approval process. So he definitely shouldn't be changing production code. And he shouldn't have access to the SaaS products because that's not his remit. That's not his team. He definitely shouldn't have access to your data. He shouldn't be able to turn everything off. And he shouldn't be able to mine crypto on company infrastructure. That all sounds pretty reasonable, right? He's a developer who pushes code and it needs to be reviewed. That's his remit. So let's look at that in reality. This is a simplified network. He works from home, so he connects over the internet. He connects to, in their case, they're using GitLab. They're using a self-hosted GitLab, which may or may not matter depending on how you're assessing these systems. He can access the test branches, but he can't access master branches, and that's how they delineated between who would be a lead developer. I think only 2 people could realistically access the master branches. And what he can do with this is his product occasionally needs to run on OS X for certain customers. So in order to test that, it's quite tricky. So they have a Mac Mini that's sitting on his desk somewhere in an office. It's a physical little Mac Mini that's plugged into their network. And it's got a runner agent installed on it, and he can push instructions to it, and it will take his code, build it, and test it for him. They only have one, and that will be important later. Why they only have one, we'll find out. The Mac Mini essentially is on their internal corporate network. So if you go into their office and plugged in a cable, you would get the same sort of network access. Their network is quite flat, and everything is on the same network and not segregated. Potential problem for later. And it will build things and push it into storage for him. If he needs to access the network to potentially get to storage, he goes through the VPN. It's got MFA on it. He has a little token enrolled on his phone. Pretty good. Also, he needs to access Office 365 to get to his email, SharePoint, all that sort of corporate stuff. And an astute eye will quickly notice the lack of MFA on GitLab. So the threat scenario that we're sort of looking at here is if you compromise developer Dave's account, what can go wrong? In this case, you could phish Dave. We just saw some incident response processes around what that might look like. He could have been phished. He could be reusing the same password. This is very, very common. That got released in another breach. And somebody sprayed it against various accounts that are facing the internet. Maybe his password is the same for both. Normally, that wouldn't matter if you had MFA on these things. It wouldn't matter if your password got leaked. In this case, because of COVID, developers got really upset having MFA on GitLab because every day they had to push the button, and every time they were trying to commit code, it was adding an extra step. So they turned it off. There were better ways to do it. They didn't need to turn it off, but it solved the problem, and then everybody kind of forgot about it. So as a red team, we've got developer Dave's password. We can't access the VPN because we can't get through his MFA. Even if we spam him a whole bunch, he's not going to hit approve. He's not going to accept that. Similarly, we can't get to his email account. We can't get to the Azure environment or anything like that. That might get us further. Instead, we have to go through GitLab, but we can't push to master branches because we're only functioning as his identity. We're not a high-powered user. So what can we do with that? Well, as previously mentioned, there's a Mac Mini that's running that has an agent installed on it. And GitLab has it enrolled to itself, and Dave can create code that can be pushed to it, but beyond that, he has no real concept of what it does. These are separate compute boxes that he can push a script, and a result will come back in a couple of minutes, and it says all test cases passed. Here, we're going to see if this demo works. Hopefully, the infrastructure still works. So, for context, we're going to do this with GitHub. This is the SaaS GitHub to make it more accessible to everybody here. But the same concepts apply in all of these different systems. They're very, very similar. A lot of this you can do right now for free on your own as well, by the way. And I'll point out some of that as we go. So this is, say we've got an organization and there's 2 repositories, and that will become important later. We've got a private testing repository and we've got a mobile app. Let's say that that's what Dave is building. And this is from an admin's perspective in this. This is not Dave's perspective. But if you see in here, from an organizational standpoint, these things have secrets, which will become very relevant later. We've got AWS secrets, we've got production keys for what looks like an S3 bucket, which is S3 storage bucket, which is typically used, it might build something and push it to storage. Just as an example of a secret that might get passed in. And if you see in here, if you wanted to set this up, you could totally do this yourself. In general, this is the default standard settings. I have not fiddled with this at all, which basically just says everybody can use workflows or actions, GitHub Actions is what they call them, to do whatever they need to do. And we'll see what that looks like in a second. But also I've got a runner set up. It's called production runner. It's in the default group, which is very common. It's tagged as self-hosted, and it's a Linux VM. It's currently idle, no one's using it. If we go over to this view, so this is a different account. This is Dave's account, his low-powered account. And an important distinction here is he only sees the mobile app. He doesn't see that private testing repository. That's disappeared. But in here, say he was to commit code. If you had access to his account, what you might try and do is modify one of these files. Let's, just for the sake of testing, show us what that looks like. If we try and propose this change, you'll see I'm not allowed to commit to main because it's a protected branch, and this is quite normal. Dave's not high-powered enough. He needs to get approved. But if you did push this button, and you should never do this because it will generate a whole bunch of alerts. See, it looks good, and then requires approval. So this will send off a bunch of emails to Dave's boss. This will potentially alert somebody. Then the incident response team might get called in, and bad things will happen. We want to remain stealthy as we do this. So imagining we didn't immediately go for that, what you could do with his account is up here, you could potentially try to submit this as a different branch. And this is where a lot of the default settings fall apart. If we create a new branch, Dave's allowed to do that. Different branches, particularly master or main or whatever you want to call them, should have runners attached to them that are configured specifically for them. And almost no organization does this correctly. And in here, if you've never seen what like a GitHub workflow or a pipeline looks like, they'll have these special directories like a .github and then the workflows, and in this case, there's a run.yaml file. Everybody read that okay? Make that a bit bigger. And this is a very common thing that you might see. Basically what this is saying is whenever something's pushed to the repo, and in particular this branch, or we can do it manually is what this means, we want to run an Ubuntu latest. In GitHub world, this means it will go off and spin up a SaaS VM. It's actually in AWS. GitHub does this for you. It's totally free, and it will run whatever this YAML tells it to do. We trust, on some level, GitHub to do this correctly for us. It's very containerized. It's very hardened. What you might want to do, though, if you're an organization that Dave works for, is have your own runner that's on your internal network, like the Mac Mini. GitHub can't cover all cases. It can't run on a physical device for you. It can't access your internal network. Maybe it needs to get to a database or specific storage. There's various reasons why you might have your own self-hosted runner, and that's what we're really looking at today. Using the SaaS version of this, in my experience, pretty safe to do. So if we look at actions up here, if you wanted to run the existing YAML that's there right now, you could say run this workflow against the main branch. Remember, I'm not modifying it, I'm just telling it to run what's already there that's been approved. This will fire off an event. And demo God's willing, it will appear. There we go. It's already running, it's in progress. It's done, it's nice and quick. These can have multiple steps. These can be massive things that take a whole day to run. But the basics of it is automatically something's gone away and created a Ubuntu because that's what we asked for. You can see all the image that it was running. It's got a GitHub token with all of these permissions attached to it, which can be quite interesting. It's checked out our code, so it's pulled down a copy of it to this temporary directory, and then it's run. In this case, we gave it a multi-line script. Basically, we just gave it a bash script. And the script that we gave it was, we want to echo something out, we want it to tell us its host name, how long it's been up, and any environment variables that it has. In this case, this thing right now, it's FVAZ, blah, blah, blah. This is some automatically generated thing. It's been up for a minute. And these are all of its environment variables. It's got Go installed, it's got Selenium, it's got Python, it's got all sorts of stuff. And you'll see here it's redacted something automatically for us, which will be interesting later as well. This is an instance running in AWS. As I said, that's a SaaS one. But if you wanted to run, if you were a malicious Dave, and you went to your new branch, not this branch, there's nothing stopping me from editing this because this is my branch that I created. This isn't a master branch, it's not protected. And I have a payload prepared for us. That has wonky spacing. Cool, so this is very similar, but this time we've changed runs on to self-hosted. And if you remember before, when I was showing you the runner that I had, it was tagged as self-hosted. That was the default tag that it gets, and this is very, very common. You'll see this everywhere. And in this case, I'm asking it to get some environment variables that are some secrets from secret storage that we saw before, and we're going to try and echo them out. And we'll see here we are allowed to commit directly to this. There's no review process that goes into this. My boss won't know. There's no email. Doesn't matter because we haven't flagged this as a protected action. So we've committed that. We've updated it. It's a little wonky, the interface for this, but we want to run this from our alternate branch now, which now has different code in it that we've changed. So we've changed it from run in SaaS land to run on our private self-hosted runner, essentially. And you can see here it's queued up. And it's working. That's always good. And it's done a very similar thing. It's set up our job, and it's checked out our code, and then it's run our script. This time you'll see, though, so it's running on that production runner. So that's my VM. That's a self-hosted thing that's not running in AWS anymore. Its username is runner. It's got some uptime. It's got Python installed, which could be good. And then you see this redaction. It does this automatically to protect you from stupidly putting secrets into logs. As a developer, though, there's nothing stopping you from deliberately breaking that redaction, for example. Just know that this exists. If you strip a character and then get the character independently and stick them next to each other, it will spit out the key without redacting it. So any sort of secret that gets given to a developer in this sense, there's nothing stopping a developer from pulling it out. This is an AWS key. You could now use Dave's account to pull out the AWS key and use it to potentially get to their S3 bucket storage or wherever they're storing their production data. So secrets alone, used in this way, given to developers, even though I'm running in a different environment, it's not the main master branch, lots of organizations screw this up and give way too many people access to these sorts of secrets. And so now, if you think about the scenario that we had before, this isn't Dave's job. Dave shouldn't be able to run on this thing necessarily. You shouldn't be able to just change between runners willy-nilly, yet he has access to run on this. So if we make one final change, and this is what I highly recommend everybody do if you ever encounter an on-prem runner like this. This is not the right instance of this. Here's one I've prepared earlier that has a reverse shell in it, basically. So we saw that it's running Python, and you could use any commands here to sort of enumerate what environment you're running inside of. In this case, we can see it's running Python. You could also push tools into your own repository, check them in, and then it would have it automatically pull it down. We might want to avoid doing that for the sake of keeping things quiet, because there might be endpoint detection tools on the VM that's running all of this that might detect like a foreign binary turning up on it that it's not expecting. But in this case, it already has Python, so it shouldn't look weird. And if we run this, I swear I tested this. Give me a second, I will fix it. There we go. I swear I tested this right before I walked in. Is that going to come back? There we go. So up the top here, we've got the runner itself. So I'm SSH'd inside of it. And if we watch it for all Python processes that run on it, and then down here we've got a hostile attacker red team style server that's sitting on the internet listening for a reverse shell to come back to it. So we're listening on port 9999, and I will run this again. If everything is working correctly. There we go. You see a Python, that's my exact code that I asked it to run. It's sitting there waiting for this job to terminate. It's running some Python. It doesn't know what it is. In reality, it's called back to my server, and it's opened up just a simple netcat listener is what I'm catching this with. So now down here, my hostile server, I have a reverse shell connected inside their runner. So if you imagine this is the Mac Mini, that's now inside their network. It's on their internal network, and you shouldn't be necessarily able to break out of this, depending on how it's configured, but most runners aren't configured to containerize workloads. That's one way to prevent this. It's a system that's designed to run arbitrary code for you, but it should contain where you're allowed to get from this. The Mac Mini, definitely not set up to do that. Interesting things that you can do from in here, you'll see I drop into this work, mobile app, that's our repository, so it's pulled down the source code for us. If we look inside here, you'll also see there's the private testing repository that we couldn't see from Dave's account. So he shouldn't be able to even see this source code, but because he's able to execute code on this runner, he can now see a private repository that maybe was never intended for his eyes. And if we think about what these runners actually do, they pull down copies of everything in there. So Dave can now see all the source code for a different repository that he was never intended to see. In here, you might have, for example, a private key, for example, that somebody's using to test to access another environment. Other things that he can potentially do is, if you think about what this thing is doing, it's building jobs automatically for other people once code has already been approved. So if you submit code and it gets reviewed and approved, somebody says, yep, all good, push it to production, it's going to go through this thing after it's been approved. So any changes that you make here as source code comes in, if you automatically make changes, it will get pushed to production, no approval necessary, who's going to know? There's this implicit trust that this machine isn't being fiddled with, basically. And from here, you could definitely infect any run that comes through this. You could infect production builds of the product before it gets pushed out, anything like that. Final thing that you'd want to look for if you're ever accessing a runner like this is any secrets that it has that's unique to the runner itself. The runner doesn't run as a user identity, it's a machine identity, so it often doesn't have MFA attached to any secrets that it has, and it needs to be able to push things, for example, to an AWS S3 bucket. So if you looked in this user, you could see here it has a .aws directory, and in here it would have credentials that it would use automatically. And so again, that would be another way to find things like AWS keys or GCP keys or whatever. Depending on how high-powered these are, you could pull these out. You could easily use tools to enumerate what permissions are attached to them. If this thing is able to create VMs, for example, you can now spin up compute at somebody else's cost. This is kind of what a very typical runner environment would look like, and a lot of environments are relatively temporary. They might get torn down every 24 hours, and that's why organizations say, oh, it's fine, we don't need to harden it as much, we don't care if something goes wrong if it breaks, because they're always rebuilding it. And they don't care if it breaks from a functional standpoint, but they don't really consider what can you do despite how high-powered this thing is. We're giving it to Dave to run arbitrary code on as a feature, not as a bug. This thing is designed to be exploited, basically. Cool. And that should be demo over. Just know that this exists for all different repository types. You can plug and play them all together. And if you want to play with this, you can use the SAS GitHub hosted stuff totally for free. You could sign up and do it right now. Cool. Let me jump back forward. So what have we done today? We've got onto his Mac Mini. And now we have persistence out of their environment. We're on a piece of compute that's running inside their internal network. That's a relatively flat network as this relatively high-powered machine. We know we can infect things from here, but also we can now use it to pivot and attack the rest of their network, which is sort of out of scope for this talk. But it's an interesting problem that these runners have, particularly if they're hosted internally, is how much access do they have to other resources internally. In this case, we were able to pivot from this to attack other people's laptops, compromise their domain controller, and also they had a trust set up for Office 365 that said anybody coming from their office internally, so if you're in the office, you don't need to MFA. You can see the logic behind it, but it's not a good idea. So in this case, now we have bypassed that MFA step and we can get to Dave or whoever else's account internally that we compromise, we can get to all of their Azure resources. At that point, you're kind of one step away from compromising the right IT admin and getting access to their account and bypassing their MFA. But the master branch is still here. And who uses that? So this is where like a lead developer who's more high-powered, who's more trusted by the organization might be coming in. And remember that they use the same resources as well. They're running jobs on the same runners as well. But also there are other runners that exist, particularly for this organization. They had shared runners. They had about 20 of them. I call them shared runners because they were broadly accessible to anybody. They also had production-specific ones. But if you think about how they've shared them to all the developers. So Dave has it and Lenny has it, despite working in two different teams or two different products. They're responsible for not over-consuming resources on the wrong runner, and so long as everybody's actually doing their job and not going rogue, that will work day to day. But from David's account, you could potentially run on other runners that he was never intended to be empowered with. In this case, they had them running in AWS for their SaaS product. So this automatically spun stuff up in AWS, created compute resources, and published things to the internet. It controlled firewall rules, it controlled load balancing. And Dave's account can run on these. That's also run by a higher powered user like Lenny. So in the same way that we can get a reverse shell inside the Mac Mini, we can get a reverse shell inside one of these, sit and wait for a high-powered user to run a job through it and have their identity and credentials run through it, and then infect those and pivot from there. These things also have high-powered infrastructure as code, is a common kind of concept and paradigm that they use, which is there's source code that drives infrastructure creation. And if you change that source code as it comes through, you're changing the infrastructure creation. So if it says we need 2 VMs for this, for load balancing purposes, you can say we need 10 VMs for this, and 8 of them go over here and are exposed to the internet, and let me SSH into them automatically. And this was the case for this. These runners had basically the keys to the kingdom. They had production access to pretty much anything, and you could definitely run up an enormous bill using these. All because Dave had a runner given to him for a test branch. Ultimately, the things that you want to look for, if you're ever looking at one of these systems because you're a developer or a hacker who's got into one of these environments, you'd want to look at, can developers create branches to things that should otherwise be restricted? Often that restriction and using a branch creation to get around it is massively overlooked in most organizations. And then this is a good sample case of an organization that has a very hard perimeter. They had MFA on almost everything, but a very soft internal network. Once you're in, you could access pretty much everything pretty quickly. And just to round that out, so we're talking accessing patient records, we're turning off their entire SaaS product, which is used by health professionals throughout the country, and then potentially pivoting to other services. We've hit test and production segregation. We've hit creating holes in networks, kind of hit the secret handling, but maybe not so much. So we've got one other example. If we're good for time, I think, that I want to run you through. There's no demo attached to this, so it should be a bit quicker. But it's an example of, in this case, we're talking about a bank, a very large bank. A lot of people in this room have probably used them at some point. And if we think about this from the ops side of DevOps, we've got the IT owner, Izzy, who is not a developer, but who is responsible for IT creation, maintenance, having relatively trusted, high-powered access to create these things. So as a result, she doesn't necessarily use the things that she's creating for, in this case, a developer. And what this person did at this bank was they manually created a master runner that they would manually enroll. And I believe this was done with PowerShell. They had a bunch of PowerShell scripts that would create a fleet of automatically enrolled self-hosted GitHub runners. And that was kind of the extent of what they needed to do. They've provisioned the compute, and I think they did some labeling in terms of test and production. But mostly this is driven by the developers. The developers want 3 test ones, 2 production ones, whatever it might be. In reality, this is more like 50 VMs. But basically, they split them test and production, and how it was designed to work in GCP and Google Cloud was test environments have access to KMS, and they should be fed test secrets, so KMS being the key management system that can decrypt secrets. So you feed it an encrypted blob, and it will decrypt it for you and give you a decrypted result. Similarly for production, but they should be very separate. So we're not contaminating the test and production environments anymore like we saw before, so that's good. And then in reality, they had a lot of developers in any given day interacting with these things. So it's impossible to kind of keep an eye on necessarily everyone. They would commit code to their GitHub, and they would have encrypted secrets in there, which is kind of a good idea. If you feed the job the test secrets, it can go into a test environment. It can go off to the KMS and decrypt its test secrets and run as whatever it needs access to. And that's quite a sensible way to do it. This way, developers don't need to see the actual passwords. There's no fear of them being copied out or anything, and they're easy to update and roll. And you can switch between environments by switching between different sets of credentials. And if you don't have access to the right type of credential, then it just won't work. It won't run. Say you've got a rogue intern, and this was kind of the assignment for this, that we were asked to look at as a case of what's the worst case if a developer went rogue? What can a day one intern do? Surely they can't bring down the bank, right? Let's assume something goes wrong. Maybe their laptop gets stolen. Maybe somebody threatens them with a hammer. Whatever it is, what could a rogue intern, day one intern do? If they're able to, basically similar to Dave, they shouldn't have access to production. And what we realized was because of the way anybody can see the encrypted secrets, because they're not protected, they're encrypted. It doesn't matter if anybody can see them, so long as you can't decrypt them, was the theory. You could take the production encrypted blobs, send them off to the test environment, which was over-provisioned with access to decrypt both test and prod. And this was an artifact created by the IT owner. When they originally created this, if you think back to the PowerShell script, just created a whole bunch of different compute with roughly the same permissions for everything, and then let the developers assign these are test and these are production. The developers don't know, unless you deliberately try to go rogue like this, that they're overpowered, and the IT owner doesn't necessarily know which piece of infrastructure is going to be used for what. So in reality, the test compute, the test VMs, could go off to KMS with a production secret, and KMS doesn't really care because it was made by the right person, it had the right level of power, so it would decrypt it for you. And as a result, anyone who has access to their internal repositories could ship off a job to a test environment that freely 200 plus developers had access to, and you could start decrypting very, very high-powered secrets. This is a case of they did almost everything right. They segregated test and production pretty well. They had the right idea, but then it fell down at the identity step. And I guess that's the key takeaway for this scenario, is that runners have their own identity and permissions attached to them. And if you're ever attacking these things or looking into them, you should really delve into what kind of permissions are attached to them, because anyone can submit a job to them, but they don't run as those people. So if Alex submits a job, it still runs as a machine account that has a certain amount of privileges given to it. And in this case, it was massively over-provisioned in terms of the access that it had. In this case, the true impact was you likely be able to access customer banking records. You'd be able to move money if you were particularly crafty with it. And more simply, you could probably cripple banking for a day or two by turning things off and needing an investigation. You can imagine with 200 plus developers in a very large banking organization, how long the incident for that might take. That could take weeks, months of downtime and lost revenue and things like that. So to round all of this out, this is my last slide. My aim is from the offensive red team side of things in the interest of weaponizing people, but you could invert this as an improvement for developer practices. I'm not going to go through all of these things, but this is kind of a quick cheat sheet that sort of I've developed for when looking at these things that you could apply to all the different GitHubs, GitLabs, whatever it is. Dev.azures, they all have these similar concepts, they just use different names. But largely you could run through this checklist, and I'm pretty sure every single organization I've looked at over the last year that has any of these, something on this list they've done wrong, and that gives you access to some sort of production secret or the ability to run in an environment that you shouldn't be able to, or ultimately just seeing source code, depending on the organization, just seeing source code that you're not supposed to could be a big secret to them. Some organizations, it's not their secret source. Some organizations, very protective over their source code, and if you could leak that, that alone would be massively damaging and make the news sort of thing for them. So if there's any questions, feel free to shout out. Otherwise, this is what I wanted to weaponize this audience based on. So thank you.